Good afternoon to all attendees present over here. On behalf of University of Engineering and Management and the Institute of Engineering and Management, we welcome you all to this distinguished lecture organized by the IETE Student Forum of the University of Engineering and Management, UEM Jaipur. The title of the topic is IoT Security, Challenges and its Remedy. And with me, you can see on screen, you can see Dr. Poonam Jindal, who is the speaker for today's webinar. And she will be speaking on this topic, IoT security, challenges and its remedy. Now, IoT has been one of the most talked about topic of late, and we can all understand that work from home being the new work culture, the need of IoT in industry will be furthermore, because even the factory owners want to operate their factory machines right from sitting at their home. So that this IoT is going to get more and more popular in coming days. That is what we can expect. And that's why I can see around 100 plus now, around 150 plus attendees already on board, and we are expecting more people to join soon. Now, to a little bit about our speaker, Dr. Poonam Jindal, madam. Dr. Poonam Jindal, she is from the Department of Electronics and Communication Engineering, National Institute of Technology, Kurukshetra. She had completed her PhD from NIT Kurukshetra itself. Her research interests include wireless network security, cryptography, physical layer security, wireless communication, and IoT security. Now, as you can understand, IoT being very important, IoT security, it will draw more and more interest. Dr. Jindal has published more than 30 international journal and conference papers in reputed publication houses. So it's a big team of teachers and students waiting to hear from you, madam. From here, I should stop. It's all over to you. We welcome you on board. Thank you.
Thank you, sir. Thank you. So a very good morning to all of you present here, and I wish you all happy Tej, and I hope you all are safe in this pandemic COVID-19. So myself, Dr. Poonam Jindal, I am with Electronics and Communication Engineering Department, NIT Kurukshetra. Today, I am going to present my talk on IoT security, vulnerabilities, and research challenges. I'll move. Sir, my slide is not moving. It got stuck. Can you please help me?
Yeah, your slide, it will change. It will change gradually.
Yeah, now it is done. Thank you so much. So I will start with the brief introduction, brief define of IoT, moving to the IoT actors and constraints. What is IoT security? What are the various architectural issues, IoT technology issues, IoT security mechanisms, then little bit overview of lightweight cryptography, which is the buzzword today to providing security to IoT, and then for research gaps, I'll discuss some research issues on which you people can work. What are the research areas? What are the various issues in IoT security? So, what is IoT basically? Let us see ourselves. You people are sitting. How many devices you people are carrying which are connected to the internet? It is believed that on this planet, 3 or 4 devices per person are connected to the internet, which will soar to 10:1 by 2025. So that means we are finding every person, every device is finding its way to the internet. Like we want everything to be automated. I'm coming back from my office. I want my ACs to be on. I want my house to be safe. It will lock automatically when I move out of my house. So likewise, connected vehicles. Vehicles are now connected to avoid any kind of accident or any kind of mishappening. Then sensors in the cars, which will record the temperature, the outside, inside. Smart factories, smart pipelines to find the leakage. at earlier stages, medical devices. Your medical devices are embedded into your body, and so that your complete data will be given to your doctors for the timely assistance. Similarly, medical assistance. If something happens on the road, if your vehicles are connected, you can easily get the ambulance. You will get the ambulance on time. Smart cities, smart traffic light systems, smart parkings, smart meters, self-driven mining equipment. So this is how we are now connected. Every device is connected. That is, we are finding the way to the internet to ease our lives. So this move to connect to the internet is basically Internet of Things. It is nothing but the integration of cyber world with the physical world, so that we can access anything, anywhere, and anytime. So this is what IoT is. Integration of cyber world with the physical world. So IoT is basically named in the different manner in the different literature. Somewhere you will find it is M to M, machine to machine, which is nothing but Internet of Things. IoT or IoE, Internet of Everything. Cisco termed it as Internet of Everything. Bruce Senior, the cryptographer, he termed IoT as the world size web. Terminator, you have seen the movie Terminator. They have named it as Skynet, but it is nothing but the different names of the same concept, that is Internet of Things. Now let us see, where is IoT? IoT is basically everywhere. Everywhere, like your smart wearables. You people are wearing smart watches, smart devices. Like when you are smartwatch scans everything about you, your number of footsteps, your body temperature, your heartbeat. So it completely scans you. Like smart markets. If your every product in the market is RFID enabled, then the moment you are doing your shopping, the bill will generate it automatically. And same, if your refrigerators are RFID enabled, your refrigerators, there are tags, RFID tags are there, then it will keep the record of when you are putting the item in the fridge, when it will when it is going to expire. And similarly, while you are on shopping, you can simply check your phone that which of my item is expire soon. So how easy it is. You need not to make the list of the products and so on. Similarly, in hospitals, smart grids. So everything is smart. So we can say IoT is everywhere. You can access anything, anytime, and anywhere. This is what IoT is. This is a simple example, simple view of the smart Internet of Things. Schools, how beautiful it is. If schools are your IoT enabled, your everything is smart. Smart playgrounds, smart labs, smart attendance system, smart checking system. So smart labs and attendance can be made with smart parkings. So the smart Internet of School. How IoT is growing. There is a tremendous growth in IoTs. As of 2013, the 9.1 billion of IoT units were there, which is now has raised to 28.1 billion of IoT devices, and which is expected to rise to 50 billion by 2025. So is the revenue. Revenue rate by 2013 was simply $1.9 trillion. Now it has raised to 7.1 trillion by 2020 and many more by 2025. So Internet of Everything, Internet of Things is nothing but it is the networked connection. It is bringing together people, people, data, things, and processes. It is bringing together the people, data, things, and processes. So people connect, it is connecting the people in more relevant and valuable ways. It to deliver the right data, right information to the right person by leveraging data into more useful and decision making, by decision making. Things, physical devices and objects connected to the internet and each other for intelligent decision making. So it is connecting the people, processes, data and things. So it is again struck. I think some. Excuse me, sir. Again, it is struck my PPT. I'm not able to scroll down my presentation.
Yeah, it will just take maybe some time, madam, because your internet
Sure.
has got some issues. So I'm sure that it will just.
Okay. Now it is done. Thank you so much.
Yeah.
Sorry for the inconvenience. Okay. Now, if we see, IoT has different perspectives. If we see with the technological perspective, what we are seeing that there is total abrupt or drastic change in the technology when we are working with IoT. Traditionally, this technology we were working traditionally, now it's not supported by IoT. So IoT requires context-based technological advancements. So upgrading, migrating, compliance or deleting existing technology is required. And to integrate the new technology, but not by affecting the service providers and service consumers based on the application. So it is a paradigm shift in all sectors of technological front. So a significant change in organization and societal progress. But when we see from business perspective, it is giving the tremendous potential to electronic business. We can see numerous amount of devices are there which are required to be IoT enabled. We want every day, I want MI band 1, I want MI band 2. So with each progress, with each development, evolution, we want that device. So it is going to scale up in multiple folds and it is great beneficiary to industry. Another is economic perspective. If we see IoT from economic perspective, it has two ends, consumer and supplier. Consumer, we. So it helps us in time management, in giving us flexibility and security. Suppliers, for suppliers, it generates great revenues. From human perspective, human minds can be used in IoT in a controlled way, depending upon consumer and supplier requirements. So these are the different perspectives of IoT. But now what is a great issue with the IoT? Great issue is it is a resource constrained devices which have low cost, low power, low memory, limited computation capabilities, which can communicate on short distances like wireless sensor networks, radio frequency identification, then sense environmental data and perform limited data processing. So the devices which gather the information, which collect the information from the environment are resource constrained. So can you think, what do you think, what will happen if devices are resource constrained? Can we use the conventional technology with these resource constrained devices? No, we cannot use, because altogether we need a new technology or we need to modify the existing technology to make it comfortable with to make it usable with the IoT technology. So who are the IoT actors? IoT actors are basically the sensors and the actuators. In this, what happens is IoT devices, they send information to the cloud, and where the data is processed, the whole information, numerous amount of data is collected, which is sent to the cloud. Then there in the cloud, using the machine learning or artificial intelligence, some smart decisions are made, and this intelligence of the device makes IoT smart. So sensors collect the information, sent to the cloud via communication infrastructure. So communication, what is a communication infrastructure? How the information is transmitted? The information is transmitted by using the radio links, radio wave. We can see, we know that wireless communication, when we talk about the security in wireless communication, wireless network, we always say that wireless networks are not secure because data is transmitted over the air. When data is transmitted over the air, which has no physical boundaries, anybody within the access range with the powerful transceivers can intercept your data. So that means when data is on the air, it is susceptible to number of security attacks. So providing security in IoT is a critical issue which is required to be addressed. Now, what is security? We all talk about security. What is security? It is state of being protected against unauthorized access. Even we think that security, we want to protect ourselves. So it has different ways, like in computers, computer security, information security, network security, internet security, and IoT security. We use different means to protect these different domains. Like computer security, we use antivirus, we use firewalls. Information security, we use different encryption algorithms to protect our files. We encrypt our files. Network security, different network security protocols are used. Internet security, IP security we use. Similarly, now in IoT is again with all these measures we can, depending upon the application, we provide security measures. Now, what is the measure of security? How will you measure the security? Broadly, we can say that the amount of an effort put in by the cryptanalysis intruder, the amount of the effort put in by the intruder to break any crypt system. The more is the effort put in by the intruder, more is the security. Lesser the effort, lesser will be the security. Basically, it is defined in two terms: computational security and unconditional security. Now, what is computational? Number of computations are so hard, number of computations are so complex, or so that the intruder is, in spite of having large computational power, intruder is not able to break the cipher. Unconditional secure, by putting any type of effort, intruder is not able to break the cipher because the useful information is not present. This is the measure of security. Basically, how much effort an intruder needs to put in is the measure of security. Though this is a theoretical measurement, but practically you need to use some attack methods, right? Next, what is security architecture? In general, security architecture consists of three basic things: security attacks, any action that compromises the security of any organization. Attack, that is attack, where the security of the organization is compromised. Then security mechanisms, the action to prevent these attacks, the algorithms that are developed to prevent these security attacks. Then security services. To achieve the security, we need our data to provide certain security services. I'll show you all the security services. So these are the basic components of the security architecture. Any developer, any security researcher will work on these three components. What are the different security attacks to any organization or any information or any data? Then what kind of attack it is, and this kind of attack will be overcome by what kind of security mechanism, and that security mechanism will be developed to achieve certain security services, right? So three components in security architecture. Next, we have security attacks. What are the different security attacks? like I have mentioned, security broadly, they are classified into two categories: passive attacks and active attacks. Passive attacks are attacks in which the intruder cannot modify the contents. He can only, like A is communicating, A is sending some data to B, and I am C, the intruder. I can simply read the contents of the data that is transmitting from A to B. I cannot change the content. That are the passive attacks. And second, that is eavesdropping. Then traffic analysis, intruder is simply watching the data, how many number of packets are there, what is the size of the packet, from where the packet is coming and where it is routing to, what is the route of the packet, like this. Then active attacks. Passive attacks are difficult to see, to observe, because intruder is not changing any data. Active attacks, where the modification to the data can be done. There are different categories of active attacks. Basically, the practical attacks, real-time attacks, all are based on these broad categories. Some are active, some are passive. Like first, impersonation. Impersonation is nothing but masquerade. Masquerade, some other entity pretends to be the genuine one. Data is coming from A, and A and B are the genuine user. I am C. C is pretending that I am A. Data is I am the authorized user. Then modification, contents are modified. Some intruder will capture the data. He will add or delete some of his entities in the data and resend it to the D. Then denial of service. A will disrupt the system, disrupt the network to stop the communication between A and B. This is denial. This is the most affected and most common attack in wireless communication in IoTs. Distributed, its higher version is distributed denial of service, where many computers send the junk data to disrupt the whole system, right? So distributed denials of service is the subcategory of denial of service, but at the large scale. Then replay, intruder captures the data, keep it with itself. When its value is over, he will resend the data. Non-repudiation, denial by any sender or receiver that I have not sent. Very common example I can give you for non-repudiation, like you are dealing with your share market. You are sending some instructions to your broker that these shares are in a benefit, please make the transaction with this, but later on they goes into losses. Then you say that I have not instructed you regarding this. This is non-reputation. Either the sender or the receiver denies the communication, denies the transmission. So we need some strong mechanisms to prevent these security attacks. See, security is always ever evolving area. You can't say now your system is all secure. If you develop one new mechanism, one new attack will be there. So it is ever evolving area. There is a great scope of research in this area. Security mechanisms, I have the second component of security architecture are security mechanisms. This is how we can classify on the basis of cryptographic primitives. Two things are there, two mechanisms are there. Security mechanisms, either the security can be provided with the cryptographic primitives or with at the physical layer. It has different signs. Physical layer security is a different field where you provide the security at the very first layer, at the perception layer of IoT. The cryptography classified into symmetric and asymmetric key cryptography. Some hash functions are used, some MAC functions are used. Again, symmetric is for the stream ciphers and block ciphers. These are the overview of your cryptographic primitives. Then we have security services, the most important part. Security service, like I want confidentiality. Confidentiality is, what is confidentiality? You must have heard about CIA security. CIA is what? It is confidentiality, integrity, and authentication. Confidentiality to maintain to ensure that your data has not been read by anyone. And with what security mechanisms you will get the confidentiality? By symmetric key cryptography is used to provide confidentiality. See, there are a lot of applications, lot of scenarios in which we work. Everywhere we don't want authentication. Everywhere we don't want confidentiality. Everywhere we don't want non-reputation. So depending upon the application, depending upon the requirement, we use different mechanisms to provide different security services. Confidentiality ensures that your data has not been read by anyone. Integrity ensures that the data has not been modified by anyone. And authentication, the important, which is very important in IoTs. Why it is important? Authentication is basically the verification of the credentials of the communicating entities, right? When you log into your computers, your emails, your websites, right, any social media, what do? You enter your user ID, you enter your password. Why you are not giving access at once without entering the password? Because you are authenticating yourself by entering the password to the server, to the Facebook, to the Gmail. Yes, I know the password, I am the genuine user. Basically, authentication happens in 3 ways. On the basis of what you know, your passwords, what you have, your cards like driving license, your credit cards, and what you are, your biometric. So authentication are like you can see Aadhaar cards. It is high level of authentication is there. Your biometric is there, your number is there, your Aadhaar card, your card you have. So it is a 3-way authentication to know the entities, to ensure that only the authorized entities are communicating. Authentication is very important in IoTs. Then authorization. Access will be given to only authorized user. Then access control. Access control, like I am a Airtel user, right? I authorize myself to Airtel by buying the card, by showing my credential. After authenticating the Airtel office will issue me a SIM card. Now I am an authorized user of Airtel. Now, am I able to access every possible service given by the Airtel office? No, I am authorized to I can access only the services for which I am authorized to. So it is required to control the access of the user, that what he can use or what he cannot. Then availability. Availability is that resources are available all the time, continuously to only the authorized users. Non-repudiation service, so that either the sender or the receiver cannot deny the communication. Non-repudiation is provided by digital signatures, where when you sign any document, even you cannot deny that you have not signed it. Non-repetition provides you the digital signature. Algorithms are used to provide these services. Okay, so next we have IoT application. These are very few I have mentioned. Like in some services, like I have mentioned, it is not necessary you need all the services to be provided using one algorithm. To provide, like like I am watching movie, I need what kind of security? I need what kind of security mechanism, so that whatever I am watching is not to be seen by anybody. Right? Integrity, authentication is not necessary. So, and similarly, but when I am doing the transactions, I am using banking, I need all the 3 services: confidentiality, integrity, or rather all the services which are given. So I will use that kind of security mechanism, right? So if we see see the security breaches in IoT. Like I have mentioned, security in IoT is different from the security in IT, conventional IT. Why? What are the various security breaches in IoT? As we have seen, a billion of connected devices are there. Everything here is connected, but at the secure and insecure locations. Security may or may not be built in and either not owned by or controlled by any IT sector. By devices are simply deployed and nobody cares about the device. So data flows through the network. Any node on your, so see, everywhere there is a breach. Security, it can be there, it cannot be there. Device is simply deployed at one place. It is deployed at remote areas. It is deployed at the areas where there is nobody can take care of the device. So any node on your network can potentially provide access to the code. Security can be compromised. If any node is compromised, your whole system can be compromised. So security challenges in IoT devices are not reachable. Most of the time, devices not connected. Devices can be lost and stolen. Devices are not crypto engines, as we have seen that they are resource constrained. Strong algorithms cannot be implemented, cannot be used in IoT nodes or devices or things. Devices have finite life. Again, finite life, low energy is there, low battery life is there, low memory is there. These are the constraints in IoT, which creates several challenges to work with IoTs. Devices need to be recognized by many readers. Again, the same point. Number of devices are there. What data is released to what reader? It is to ensure that who is communicating to whom, who is sending data to whom. It is very important to individually identify and authenticate each and every node in the process. So different security attacks, on the basis of these challenges, different security attacks are device identity attack. If device identity is not clear, not defined, then attacks are possible. Device integrity attack. Devices can be modified. Any intruder can steal your deployed device and deploy his own device. Then life cycle attacks. You must have heard about the ransomware attack. What was ransomware? That your systems, in IT sector or in banks, your systems were completely disrupted. You were not able to access the system, and you were allowed to access only if you pay some ransom to the intruder, malicious user, right? So this is ransomware. It is a life cycle attack. Your system will not be disturbed, but it will be disrupted. It won't give you any service until you fulfill the requirement of the illegitimate user. Similarly, distributed denial of service, it will completely disrupt. Many systems come together to disrupt your network. Then communication attacks are man-in-the-middle attacks. Someone sit in the middle. He either observes your communication, he either intercept your communication, your keys, and send the keys further, as if you people, A and B, are feeling that they are communicating, but they are not aware that somebody is sitting in between and reading the contents, modifying the data, and he pretends to be data is coming from A to B, B to A. Then some of the real time IoT attacks you must have heard about, like Linux DDoS. It was the attack on Linux systems which infects routers, security cameras, set-top boxes. Similarly, we have spams. Abhi bhi you people see that there are number of spams and phishing emails. Sometimes you get the email that, yes, I am your friend, email from your friend's account. Yes, I am in trouble. I am here and here. Please send me this amount. I need your help. So then it's something like this is zombie a number of messages, phishing messages are put in together to disrupt your system. Attacks can be on your smart homes. It can attack your, like if your passwords, if your voice enabled devices are there, then anyone can use this. Attacks on medical devices and hospitals. So next is how your traditional, like I have mentioned that your traditional IT security is different from IoT security. Now, what is this? Is a very common thing, when one should know that what is the difference. How IT security is different from IoT security. In IT security, we have add-on security. Like we have fixed our device, we are using some device, time to time I need some security measure, I can add security features on at this depending upon my requirement anytime, right? And but in IoT security there is built-in security, that is security is provided at the time of manufacturing, right? So we cannot use any add-on security, and even the vendors, even the manufacturers are not aware of the proper security standards. So it gives us the security breaches, which makes the device vulnerable to security attacks. Then we have complex algorithms. In traditional IT security, traditional conventional security algorithms were complex. So were the devices. They were able to handle the complex algorithms. But IoT security, due to the constraints, it can handle only the lightweight algorithms for resource constrained devices. Then user control, collect automatically user private information. uh, Traditional IT security, that was under the control of user. Means user know what data is to be transmitted and what data is to be transmitted to whom. But what happens in IoT? Lot of devices, sensors are free to scan, to collect all the private information attributed to, related to any of person, right? Once we deploy the sensor, it will start sensing, it will start gathering the data, and it will start scan everything, every private information. So it was, IT security was under the control of user, but IoT security is not. Small technological heterogeneity. IT security, there was small technological heterogeneity due to the small environment, like environment. But in IoT, it is great heterogeneity, very heterogeneous environment. All the layers are working together. Data is collected. Immediately, we need to send the data. Hence, large attack surfaces there. Many security guards were there, but in IoT, few security guards were out there. Devices are deployed in closed environment, but in IoT, devices are deployed in open environment. So this is the basic difference, very basic difference between IT security and IoT security. Hello,
Hello,
am I
madam.
audible?
Yes, yes,
So
you're
again,
audible.
I'm not, now it is moved. Actually, sometimes the screen struck off. Okay,
Yeah, because
thank you.
sometimes your internet is disturbing. We are getting to understand it from your webcam also. Yeah, now it's fine.
Okay, okay. Now it's fine. Thank you. Thank you. So if we see the three-layer IoT architecture, we can see it has, though the basic functioning is similar to the network architecture that we see, the seven-layer architecture, but it consists of, if we see it from the three-layer: perception layer, the basic physical layer; where sensors are used for sensing and gathering the information, senses some physical parameters. Network layer again for collecting the other smart things, data from other smart things, network devices and servers, and transmitting and processing the sensor data. Application, the users delivering application specific services to the users, defines various applications. Internet of things, smart providing applications like smart home, smart cities, and smart health. Again, from the research point of view, we see it as a 5-layer architecture. Between the perception layer and the application layer, we have 2 more layers, that are the transport layer and the processing layer. Transport layer transfers the sensor data from the perception layer to the processing layer, and by using the networks such as 3G, 4G, LAN, Bluetooth, RFID, NFC, near field communication. And processing layer, it stores, analyzes, and processes huge amount of data. It can manage and provide a diverse set of services to the lower layers. Employs many technologies such as database, cloud computing, and big data processing model. And each and every layer has its own issues, own attacks, and security measures that can be provided at each and every. Now I'll show you some of the basic attacks. What are the security measures we take to secure each and every layer? Perception layer, again we can see the physical layer, where high level encryption, as resource constraints are there, high level encryption is not favored and very hard to implement. It will not work. Traditional conventional cryptographic algorithms cannot be implemented in IoT devices due to its resource constraints. Attacks. Denial of service attack is there, interference is there, jamming, intruder can jam your signal and disrupt your system. Jammers, intruder can put in the jammers on the channel. Then what security measures we can take? We can use CIA is important, confidentiality, integrity, and authentication of data is important. Privacy is important, authentication of nodes is very important, but due to the memory constraints, lightweight cryptography, physical layer security, and key agreement measures can be used at the perception layer. The network layer, which is relatively secure as compared to the physical layer, and again some attacks are possible like eavesdropping, traffic analysis, viruses, junk mails, distributed denial of service attacks. Then issues is network congestion will happen if there will be number of messages will be flooded into the network congestion will there and packets will drop. Security, TLS and SSL security, IP security is used, anti-distributed denial of server, and identity authentication of devices. Then application layer, again the user layer, any depending upon the application we can use different measures. Now if I do the qualitative risk analysis of IoT system, the perception layer is at the highest risk. Perception layer is the physical layer because all the data is collected at the physical layer. It is at very high risk because of the physical exposure of the IoT devices. Large hardware limitations, because again hardware limitation is there. We cannot use heavy technology to prevent these attacks, to prevent the intruders. So technologically heterogeneity that limit the implementation of effective security measures. If we see from technological point of view, this heterogeneity of the physical layer limits implementation of effective security measures. Then transportation layer, which is at lower risk level, known drawbacks are there, and people are working on the intensive research is going on the vulnerabilities of transport layer because it works in the similar manner as with the your system OSI model. But so lot of research is already going on, and the protocols, technology used is merely so continuous development of new protection methods is going on in the transportation layer, though It has security attacks, it has some vulnerabilities, but if we compare it with the perception layer, it is better in terms of security as compared to the perception layer. Third, application layer, it is variable level of risk depending upon the specific implemented application, accessible from large number of users, and in some IoT applications compared to the perception layer, it has more mature technology, less threats, and already tested security methods. Because security is basically provided at the perception layer. If our node is not properly security enabled, then it will lead to it is vulnerable to number of attacks. Application layer, we can put, like on my phone, I can add some security, but on network, different vulnerabilities are there. Then if we see security issues from IoT technology, can we use existing technology in the IoT technology? No. IoT works for IPv6 over low power wireless personal area network, which make use of routing protocol for low power and lossy networks, which is very weak, and number of security threats are there, routing challenges are there, disrupting traffic, flooding of messages, traffic analysis, active tampering attacks, resource constraint attacks are there on this technology. Then on sensor nodes, which are the basic building block of any IoT device, physical layer, again jamming, tampering, data link layer, collision and resource exhaustion, network layer, Sybil attack. It is a kind of impersonation. Intruder pretends to be the genuine. Selective forwarding, intruder catches some packets, drops some packets and sends some packets. Sinkhole, some node, malicious node pretends himself to be so attractive, so all the data traffic moves through the malicious node because it is tempting, and it is this node data will move in the better way through the malicious node. So presentation, so that is sinkhole. Hello flood, intruder sends a hello message. Your communication starts with hello message. Intruder starts a communication with hello message, and acknowledging some of the acknowledgements are dropped by the intruder. Right? In this way, number of attacks are possible. Transport layer, flooding of messages, desynchronization, to disrupt the system, to desynchronize the system. So these are the various other security issues I have mentioned mostly in the previous discussion, that is naming and identity management is must in IoT. Interoperability, different vendors, different manufacturers are designing, are developing different type of sensors, different type of devices, and to work with the common technology and common standards, it is interoperability and standardization is must. So work, because due to lack of knowledge, we are facing lot of issues in IoT. Vendors and manufacturers are not fully trained to know the standardized what are the basic requirements of IoT security. Then information privacy, data confidentiality and encryption, network security and object safety. Security measures in general, I've already discussed it. To provide the security can be, these are the basically the various areas. When we work on security, doesn't mean I am working on simply the encryption or decryption algorithms. These are the different areas on which one can work. Encryption, decryption, cryptographic primitives, these are one area. Then authentication. To work on authentication is the second thing which we require to provide the security. Key management. As see, number of users, thousands of users are working, they are interacting with each other. So how many keys we need to distribute to provide the security? I am sending some encrypting data, B is decrypting it. I need to share the key because key is the main ingredient of any encryption algorithm. So I need key management, how key will be distributed, how key will be shared between the communicating entities. Access control, who can access what is important. Then the very first layer, physical layer security, information-based security, where jammers are there, where different cooperative communication can be used, different physical layer security techniques are there. They are themselves, each and individual security measure is a plethora of problems, have plethora of problems to address. So security policies must follow the basic measures. Hardware security is required. For IoT devices, some cryptographic co-processors and anti-tampering units should be there. Access control and authentication systems are there. Data encryption mechanisms should be there. To design any security policy, secure routing should be there. One must keep all these points in mind while designing the security policy. There should be proper intrusion detection system. What is the possible threat? What is the possible attack on any particular system? Intrusion is the possible attack. Detection to detect that intrusion. Anti-malware solutions should be there. Firewalls should be there when you are working with cyber. Then trust management system should be there to ensure that the security goals are enforced. So these are the basic steps which are required to provide the security policies. Then existing security mechanisms, what we are using right now, which are useful for IoT. AES, NIST. NIST has believed and they allow AES to be used in IoT. AES is encryption algorithm. It is a symmetric key encryption algorithm which provides confidentiality with 128 bit of key and can transmit 128 bit of data. But can we process 128 bit of AES in IoTs? Because it will lead to lot of computational complexity. So AES as it is, we cannot use in IoTs. So we need to make it lightweight. We need to reduce the weight of AES, right? I'll discuss lightweight. So I won't discuss it here. Then Diffie-Hellman key exchange protocol is supported by NIST, that is National Institute of Standards and Technology, which gives some standards to be used in security. Then hash functions are used. RSA ECC, elliptic curve cryptography, is the preferred cryptographic measure for the resource constrained applications. It is an asymmetric key cryptographic mechanism which can be used to provide the security. But lot of issues, lot of research is going on to provide the best security using the ECC, intrusion detection system and intrusion prevention systems. So while securing the IoT, we need to secure the system, the node, we need to secure the application, we need to secure the mobile, we need to secure the cloud and network. Security measures are required at each and every step. Okay. Lightweight cryptography. So what is lightweight? What do you understand by this word lightweight cryptography? Does it mean that 1 kg, 2 kg, 3 kg? Is it lightweight? Lightweight basically, as I mentioned, that 128 bit AES with 16 number of rounds. Each one, 4 steps, if one round consists of 4 to 5 computations or 4 to 5 different blocks, then they will be repeated 16 times. 16 rounds are there to process 128 bit key and 128 bit of data. So is it possible to handle such complexity with IoT devices? No. So we need to reduce the block size. We need to reduce the key length. We need to reduce the number of rounds to make it light. That is why these are known as lightweight. Light in terms of their memory consumption, power consumption, number of chip area, number of gate equivalents, logic gates, memory constraints, that makes the algorithm light. So that is why this is known as lightweight cryptography. So to device capability to make it work with the resource constrained devices. Hardware implementation, so that we calculate the chip area or gate equivalence. Chip area, the area that is number of gates that are used to implement the cipher. Then software implementation, RAM and ROM, how much memory it will use. So these all components make it lightweight. So performance metrics for lightweight cryptography is again we measure the security. It is always required there should be a trade-off between security and the network, security and the lightweight cipher. It doesn't mean if we reduce the number of rounds, we reduce the key length, we reduce the block size, but at the cost of security. So there is a need to develop the ciphers who maintain the security, but not at the cost of efficiency, or to improve the efficiency, but not at the cost of security. So they are to keep the balance between both. So a lot of research is going on, but still number of attacks are there. No perfect solution still we have received. So if there are many scopes we can work on in this area. Chip area, throughput, latency, power, more or less they work with the, they can be further calculated from the chip area. Efficiency of should be high as possible for a cipher. Lightweight, like in the conventional cryptography, lightweight cryptographic primitives are in again symmetric and asymmetric or lightweight block ciphers. What is block cipher? Where we process a block of data, like 128 bit of block. Together 128 bytes or bits will be processed, and stream ciphers bit by bit processing is there, single bit processing. Then lightweight hash functions, they are mathematical functions. Then elliptic cryptography. Now I'll show you some of the research works. This is classification of cryptographic algorithms on the basis of their hardware requirements, like ultra lightweight cryptographic algorithm, which consumes hardware implement chip area up to 1000 gates with ROM and RAM capabilities. These are some mentioned, some of the algorithms. Then low cost cryptographic algorithms, then lightweight cryptographic algorithms, which can consume up to 3000 gates. So security policies at different network layers, you can say physical layers use AES, RC4, network layer use different AES, DES, so with different protocols. Low PAN, that is low wireless personal area network, low power wireless personal area network. WPA is the Wi-Fi protected access, which are used for the at the networks for wireless security. Lightweight block cipher, this table represents some of the researches that are going on to that have developed lightweight block ciphers. But again, all of them has several issues, like many attacks are mentioned in the literature on these devices. Then we have lightweight block ciphers. Then we have lightweight stream ciphers. Then hash functions. Similarly, this is just the overview of how much research has been done till date to implement the right algorithm, the strong algorithm for IoT applications. So research gaps, basically they reduce. What is the requirement? Research gap is what is not available in the till date. We need to reduce the block size, we need to reduce the key size, we need to make the rounds simple, we need to design a simple key schedules. See, key algorithm, encryption algorithm and key generation, they are again the two different research areas. They are again the two different research areas. So to generate the key distribution, we can work on key distribution as well. We can work on rounds as well. We can work on block sizes. Similarly, for the stream ciphers, we can reduce the chip area. we can reduce the key length, we can minimize the internal states and reduction of the key cycles. Hash functions reduce the output size, reduce the massive size. Similarly, for ECC, reduce energy consumption, optimization of TF and group arithmetic, and improving speed. Then again, the broad research areas on which one can work is cryptographic primitives, that is the encryption part, authentication part, key generation, as I have mentioned, how to generate a key. Key is the important ingredient of any cryptographic primitive. If key is compromised, whole of your algorithm, whole of your data will be compromised. So careful generation, key generation is intelligent key generation schemes are required so that they cannot be compromised. If key is compromised, so whatever, how much your algorithm is complex, it will be compromised. Key distribution, how key will be distributed between among all the users, because now the network is very large. Number of users are numerous number of users. So key distribution is not an easy task in IoT devices. Intrusion detection system, intrusion prevention system, physical layer security, to like we have mentioned that perception layer is at high risk because whole of the data is collected, gathered from perception layer. So to provide the security at the physical layer is very important. Then IoT security using machine learning, because now we are moving towards a smart world, smart things, everything is going to be smart with smart decision making. So machine learning is also a new paradigm for IoT security. Then cloud security, whole data is stored in the cloud. So if cloud is compromised, it will give the great losses. So various challenges and future work. So lack of large scale identification techniques of IoT devices. So device authentication, lightweight authentication, and ECC are preferred. Limited security related awareness capabilities of IoT users, which is very important. Immaturity of security protocols and standardization. The low PAN is used, but that is not a mature technology till date. Effective cryptographic primitives are required to work on cross-layer design, because IoT, all the layers are working together. So cross-layer design, cross-layer technologies are required for security optimization. Machine learning in IoT security, communication security analysis, and cloud security. So in conclusion, I will say that today billion of IoT devices are on the go. So which are transforming our lives. They have changed the way we work, the way we live, and the way we play. Now earlier we were attending the classes, we were delivering the lectures offline with the face-to-face interaction. Now the way we live and the way we work have changed. Now I am delivering my lecture online. So this is how IoT is changing our lives. Then confluence of key, it is a confluence of key technologies and market trends with fully interconnected smart world. It is the relationship between objects and people, objects and environment, and which all things are tightly intertwined. Definitely, with the potential benefits are significant. So, but there are several serious challenges which are required to be addressed to make it the blessing for us. So, to maximize the benefits while reducing the risk, improving optimized security, privacy, interoperability, and standards, legal and regulatory and right issues are required to be addressed. So we can say that if misunderstood and misconfigured, IoT poses risk to our data, privacy, and safety. But if understood and secured, IoT will enhance communications, lifestyle, and delivery of services. So this is the main. If we understand it properly, it is a blessing for us. If it is misunderstood and misconfigured, then it is curse for us. We all know this. Okay. Thank you. This is from my side. Now over to Sir, Mr. Chakravarti.
Hello, madam. It was really an insightful talk, and I'm sure that we have
Thank you.
gathered all of us have gathered a lot of information. It was full of information, full of knowledge, I would say. So it was really very beneficial, I believe, for all students and teachers who attended this. Now, there are a few questions in the question panel. So I will definitely like to pose those questions for you, madam, for you to answer if
Yeah.
you can kindly do the needful. So the first
Yes.
question is uh, from Mr. Pratik Agarwal. If number of nodes are very high, then should we
Yes.
move to IPv6 in IoT implementation?
Yes, we can move, but again, we need to make our technology modified on that depending upon the need of IoT. Resource constraint, as I have said that we are moving with the resource constraint. IPv6 with low PAN is specifically for the large to handle the large number of nodes.
Okay, so yeah, that was, I think you got your answer. Mr. Vivek Chetri asks, are
Yes.
the security architecture for IoT and wireless sensor network different?
No, it is same. Security architecture that I have discussed. These are the backbone. These three things: security attacks, security mechanisms, and security service. These three components of security architecture are the backbone of any security architecture, whether it is a sensor network, whether it is a wireless local area network, whether it is IoT. The basic architecture is same, though the requirements are different, but the basic architecture is same for all the networks.
Okay,
Yes,
so yeah, so Vivek, I really believe you got your answer. Now it is Professor Ria Sen. What are the economic impacts of the increased application of IoT?
definitely. Like I have discussed in perspectives, IoT perspectives, economy will grow as it is growing from 9.1 to 23.1 trillions by 2020, and it is expected to grow to, it will generate revenue and but for many more by 2025, because like I have mentioned, nowadays 3:1 ratio is there. One person is carrying 3 to 4 devices, and by 2025 it will raise to 10:1. So definitely the revenue will increase, economy will be affected. Great effect on economy will be there.
Okay, thank you, madam. Professor Ria, you really got your answer, I believe. So, Professor Sandeep Das, he has got two questions. I will pose the
Right,
first question firstly. How the
right.
IoT device security in perception layer is maintained?
By using the physical layer security means, physical layer security will be used to provide the security at perception layer.
Okay, and
Information
does this
security,
okay? So, does the standard encryption technique used in network security provide
right?
same security in case of IoT?
No, this is what I am mentioning throughout my talk, that the standard security encryption we cannot use in IoT as they are very complex. They are, though they are strong, but their computational complexity is very high in the conventional cryptography, standard cryptographic methods, it's metric standard encryption algorithms. But in IoT, due to the constrained resources are constrained, they cannot handle such a great complexity. So that is why lightweight cryptography is required to handle security in IoT devices.
Okay, thank you, madam. Now there's a question from Tisha Jain. She appears to be a student, definitely. We in labs generally prefer Raspberry Pi to implement prototype of our projects. Are there
Yes.
any other controllers which can deal with Python platform? If available, are they reliable and scalable enough?
Yeah, currently every student is using Raspberry Pi, but we can work with LabVIEW and some good softwares. Right now, I'm not able to recollect, but definitely there are some other, except because Raspberry Pi is not giving it is giving to you a very simple environment, very basic environment. By using Raspberry Pi, you can simply control your room. But for high level of you need IoT test beds can be generated.
Disha, I believe you got your answer. However, you can get in touch with madam for future references, if any, for the
Yeah,
exact
sure.
name of the software. Okay,
Yeah,
so
sure. I'll definitely get you.
Dippo Chakraborty, he asks, in IoT, how we can address data storage and data processing issue, especially for time-sensitive application like healthcare.
Uh, Pardon?
Okay, the question is, in IoT, how can we address data storage and data processing issue, especially for time-sensitive application like healthcare?
Data storage is again due to the constraints. We cannot store very large amount of data in with IoT applications, because the same, if we recollect, resource constraints also includes the memory constraints. It can RAM and ROM, what your device can handle, it depends. So storage is handled by the cloud. So cloud is altogether a different area.
Okay, thank you. Thank you, madam. Yeah, Piyush Krishna Kumar, he has got a question, but it is a very broad question he has asked. I'm not sure whether you can give an answer in coming 2 minutes. Anyway, madam, can you tell me about IoT security using machine
Yes.
learning in briefly?
Briefly, okay. Like in, let me take the physical layer security. Machine learning can be used for the cooperative. Basically, what physical layer security is does, like I'm using AF, cooperative communication, amplify and forward. There we need to use the relays to transmit our data, protecting from the eavesdropper. We can select a relay. We can use a machine learning to distinguish between the eavesdropper and the authorized user. Machine learning can be used to make by the data sets, by the data collected from the environment, to distinguish between the eavesdropper, the malicious node, and the authorized node. Machine learning can give you the best results.
Okay, thank you. Thank you, Piyush, for asking this. Anyway, there's one last question in the question panel. That is,
Right.
can we use IoT for underwater sensor network?
IoT for underwater sensor networks. Though it is very hard, because underwater lot of power, lot of computations are required, because underwater lot of energy is required, and we cannot do with IoTs.
Okay, thank you, madam. Shovik, I believe you got your answer. Okay, there are 4 hands raised. I am not sure whether you have wrongly, because people often wrongly raise their hands. So I read out the names: Anirban Bashak, Gautam Ghosh, Jeet Banerjee, and Swapan Shaha Chaudhary. So there are 4 hands
Yes.
raised. I will just unmute them one by one. If it is wrongly done, I will request you to kindly lower your hand. Anyway, Jeet Banerjee, I am unmuting you. I have unmuted you rather. If you want to ask a question, you can unmute yourself and go ahead. Jeet Banerjee, if you really have a question, you can kindly unmute yourself and go ahead. The same applies to Sarpanch Saha Chaudhary, Gautam and Gautam Ghosh. And Anirban Boshak, you're not connected to audio anyway. So I don't feel it is there normally. It is wrongly done. They maybe. But if anybody wants to ask a question orally, you can raise your hands. There is one more question in the question panel at the moment. Yeah, Jeet. Go ahead, Mr. Jeet. Hello, Mr. Jeet, you can go ahead. You can kindly unmute yourself and go ahead. You're muted. Okay. So I don't think there is any connection over there. Okay, so one last question from Mr. Ajay Tripathi. Difference between
Right.
IoT and IoE he wants to ask. That is, he wants to ask the specific difference between Internet of Things and Internet of Everything.
I have mentioned specifically in my presentation that IoT is Internet of Everything, which is uh, another name, simply another name for IoT, Internet of Things. I have said IoT is everywhere. It brings together data, process, people, and things. Similarly, IoT is the same. It is bringing together people, data, process, and thing. IoT is simply the another name of IoE, Internet of Everything, which is given by Bruce Senior.
Okay, thank you so much, madam. So one more, again, a question has been there in the question panel. It is an extension of the previous question from Shobhik Shah, and I
Yes,
believe this is the last question we can take. If we
right.
don't use IoT in underwater sensor network, then how do we collect data from underwater sensors, data for underwater sensors? Shobhik Shah asks.
Mm, Shobhit, I'm sorry, I'm not able to answer you this because I am not working with underwater communication, and so I can't answer you the satisfactory. I can't give you the satisfactory answer for this. I'm sorry.
Okay, so I think thank you so much, madam. I will just we have to end over here, or should
Yeah,
we take the last question that is there in the panel from Professor Rupayan Dash? Can we take it, madam? Are you having time?
yeah, sure, sure.
Okay. In rechargeable sensor network, how efficiently we can recharge the sensor nodes? That's a question from Professor Rupayan Dash.
Yes, in rechargeable sensor nodes, it depends that where your sensor is deployed. See, sensors are deployed at very remote areas. They are deployed at, we have no time to recharge the batteries because we want our node to run continuously. Rechargeable batteries, you need to remove the battery from, and you need to recharge them continuously. So it is difficult to work with rechargeables, but we need to increase the efficiency of the node.
Okay, thank you so much, madam. I think we can end over here. It was really a
Yeah,
wonderful session, and all of us got to learn many things. And I'm
thank
sure
you.
that many of the listeners over here will be connecting with you over email. So,
Yeah, sure.
madam, did you share your email ID for people if they have any questions specifically?
Yeah, sure,
Or
sure, sure.
okay,
I'll share. It is Poonam Jindal, Poonamjindal, Poonam Jindal 81 at nitkkr.ac.in.
okay. Thank you so much, madam. Thank you for being
Thank
so
you.
generous.
Thank you,
Thank
Professor
you.
Chakra.
And thanks to
Okay.
all of you for attending this. Thanks to IETE student chapter, and thanks to all the listeners and all the professors attending this. Thank you so much. Thank you.
Thank you so much.